Hello everyone, I am Bhargav, Assistant Professor in the Department of Electronics and Communication Engineering, Vardhaman College of Engineering. I am going to explain about the subject, the electromagnetic theory and transmission lines. And in this particular video, we are going to see about coordinate systems. The coordinate systems is very essential in order to understand the electromagnetic theory. Along with coordinate systems, the prerequisite is this vector calculus also. Vector algebra and vector calculus and coordinate systems can be considered as the prerequisites for the subject electromagnetic theory. Okay. In this particular lecture, as I said earlier, we are going to see about the coordinate systems. Basically, the coordinate systems are for the representation of the positions in the space or on a plane or on a line. So, in case of the coordinate systems, we have three types. One is one dimensional coordinate system, two dimensional coordinate system and three dimensional coordinate system. In case of one dimensional coordinate system, we have only one type, that is rectangular coordinate system. So, this is for the representation of the points on a line. So, on a line, any point can be represented by using this particular coordinate system. Coming to this two dimensional Cartesian coordinate system or two dimensional polar coordinate system. Basically, the rectangular coordinate system can also be called as Cartesian coordinate system, and these two dimensional coordinate systems are for the representation of the points on a sheet or on a surface plane. We can represent any point by using either this rectangular coordinate system or two dimensional polar coordinate system. And coming to the three dimensional coordinate systems, these are for the representation of the points on a space. Okay, in a space, any point can be represented by using the three dimensional coordinate systems. We have three types here. One is the rectangular coordinate system, or this can also be called as three dimensional Cartesian coordinate system, and next one is cylindrical coordinate system, and next one is spherical coordinate system. So, in case of rectangular coordinate system, one dimensional rectangular coordinate system, as I said earlier, the point on a line can be represented. So, here only one coordinate is enough, like x. If I say x is equal to 10, I can represent the position of one point on a line. But in case of two dimensional coordinate systems, we need to provide two coordinates for a point, like x comma y in case of rectangular coordinate system and rho comma phi in case of two dimensional polar coordinate system. And in case of three dimensional coordinate systems, either by using this rectangular or cylindrical or spherical, we need to provide three coordinates. So, three coordinates are required to represent a point in a space. So, if you use Cartesian or rectangular coordinate system, you need to provide the value of x, value of y, value of z, then only you can able to represent a point in a space. Similarly, in case of cylindrical coordinate system, you have to provide rho phi z, and in case of spherical coordinate system, you have to provide r theta phi. Like this you have to provide. So, three coordinates are enough to represent a point in a space, two coordinates are enough to represent a point on a surface, and one coordinate is required to represent a point on a line. Okay. Then this slide is about the symmetry. So, which type of coordinate system has to be selected? Actually, one point can be represented in the space by using rectangular coordinate system or by using cylindrical coordinate system or by using spherical coordinate system, but which one has to be preferred means that based upon our given problem. So, based upon the problem, what type of symmetry is existing in that particular problem, that we need to identify. Based on that, your coordinate system has to be selected, but the same problem can be done in three ways: by selecting the Cartesian, or by selecting the cylindrical, or by selecting the spherical coordinate system also we can able to solve. But the calculation process will become simpler if you select the proper coordinate system based upon the symmetry. For example, the problem is based upon the sheets, then it is better to select a rectangular coordinate system, or by using, if the problem is involving the coaxial cables, then it is better to select the cylindrical coordinate system, or like a point charge, then it is better to select the spherical coordinate system. Okay. So, based upon the problem symmetry, you need to select the coordinate systems. Then we will start the one dimensional Cartesian coordinate system. So, as I said earlier, in order to represent a point on a line, we go for the one dimensional Cartesian coordinate system, or this can also be called as a rectangular coordinate system. So, you take one line, I am taking this is a x axis, and on this particular line different points are there. This is one point, this is one point, this is another point. I need to specify the location of this particular point. For example, how to specify the location of this particular point? To specify the location of this particular point, we need some reference. From the reference, this much amount of distance is there towards this particular general point. That means reference is required in any coordinate system. So, this is, assume this is a street. In this particular street, many houses are there. Assume all these points are nothing but houses. Okay. So, in order to specify one particular house, I need to take the reference house. I am taking, this is my reference house. This is my reference house, and I need to specify my friend house. I need to represent my friend house. House is nothing but here points, and all these houses are available in a street. Okay. And I have taken this particular house as the reference house, and I need to represent now my friend house. This is my friend house. How to represent, how to locate my friend house, how to tell the address. Okay, specifying the locations is nothing but giving the address only. It is, all the coordinate systems are about giving the addressing for the points in the space or on a surface or in a line like this. Okay. So, now I need to specify my friend house position. How to specify? From my house I will tell, from my house 4 meters away, like that I need to specify. Did I give the correct information? Means I did not give the correct information. I said only 4 meters, but I did not specify whether I need to go right side or I need to go left side. I did not give that much that information. So, some people may go towards right side, they may reach my friend house, or some people may go this side also, left side also. So, they may go some others house, they may not go my friend house. So, that what I need to specify, I need to give now positive or negative, that also I need to specify. If I say +4, they will go towards correct path. If I say -4, they will go this side. So, right side or left side is given by, we can able to take the positive numbers and negative numbers. So, like this, by using this one dimensional Cartesian coordinate system, we can locate any point. If I take this is 0, that is the reference, then if I say 1, that is nothing but this particular location. If I say -1, that is nothing but this particular location. So, in this particular line, any point can be represented like this. So, this is about one dimensional Cartesian or rectangular coordinate system. Specifically, we can tell this is a Cartesian coordinate system only. Okay. Then we have entered into the two dimensional coordinate systems. In that, we will see the first one is the two dimensional Cartesian or rectangular coordinate system. So, now there is a surface or on the land, the houses are located like this. Previously, we have seen on one particular street how the houses are located. Now, we are seeing on one particular colony, we can able to take how the houses are located, those houses address we are specifying now. For that purpose, we go for the Cartesian two dimensional Cartesian coordinate system. And as I said earlier, we need to have two coordinates here, x and y. By having these two coordinates, we can able to represent a point on a surface or on a plane. Okay, that one we are going to see now. So, here I am taking xy axis, already you have drawn some graphs on the normal graph sheet, that is this one only. Okay. So, x axis, you know, the values are changing from -infinity to +infinity, y axis the values are changing from -infinity to +infinity. Okay. So, the x range is from -infinity to +infinity. I am writing here x value is changing from -infinity to +infinity, and y value is also changing from -infinity to +infinity. For example, I need to locate the point 2, 3. What is the procedure for locating this one? it is already you are very much familiar with this concept. Okay, you might have drawn so many graphs in your previous semesters, but once again I am repeating that one. So, x is equal to, what is x is equal to, what is y is equal to 3, or if I do not give anything, what will you do? On a plane or on a surface, if I do not mention x is equal to and y is equal to 3, the point is available on a plane, you do not know anything. Somewhere the point is available on the surface or on a graph sheet or on this particular screen. If I give x is equal to 2, some information I have given, I did not give the total address of that particular point, but I have given some information I have given regarding that particular point. What is that one? Generally, y axis is nothing but, y axis equation is x is equal to 0 and x axis equation is y is equal to 0. Now, what is x is equal to? X is equal to 2 is specifying, x is equal to 2 is specifying a vertical line which is drawn parallel to y axis at a distance of 2 units. This is x is equal to. So, x is equal to 2 is nothing but it is a line. Now, how much information we have? Our point is available on this particular line, not left side to the line, not right side to the line. That means, we are approaching to the point. Now, y is equal to 3. If I take y is equal to 3, now you do not know about x value, you have only y value. Y is equal to 3 is also a line. How can I tell that one? What is the x axis equation? Y is equal to 0. Y is equal to 3 means now I have to draw a horizontal line. Okay, this is y is equal to 3. Y is equal to 3 means a horizontal line, x is equal to means vertical line. So, if you have the information about y value, that is y is equal to 3, a horizontal line you can able to draw. Now, you can tell the point is available on that particular horizontal line, not below, not above. Now, if I give the both values x is equal to and y is equal to 3, then you will draw one vertical line which is representing x is equal to, and you will draw a horizontal line which is representing y is equal to 3, and those two lines are intersecting at one particular point. That point is your x comma y, that point is your 2 comma 3. In this manner, we are locating the points on a normal graph sheet, that is 2-dimensional Cartesian coordinate system. This is already you know, but for the completeness I have told about this one. So, here x is equal to and y is equal to 3, this is the point, like this we are going to represent. And now, I am going to give the unit vectors for this particular point. Okay. That is nothing but the Ax cap and Ay cap. Remember one thing, Ax cap and Ay cap are the unit vectors along x axis and y axis. Ax cap is always perpendicular to x is equal to constant. This statement is valid until the 3-dimensional coordinate system also, and Ay cap is perpendicular to y is equal to constant. This statement is valid up to 3-dimensional Cartesian coordinate system. Okay. So, if you see x is equal to means this vertical line x is equal to, and Ax cap direction is perpendicular to that x is equal to, this is x is equal to 2 line, already we have drawn, this is x is equal to, already we have drawn that one, and this is the Ax cap, and this is y is equal to 3. What is the Ay cap direction? This is Ay cap direction. That is why these two statements are valid. Okay. Then one more important point is, even you are locating another point like -2 -3 or -2 +4 or -2 +5, whatever it may be, you locate any other point, the directions of Ax cap and Ay cap will not be changed. Okay. The directions of the unit vectors in the Cartesian coordinate system will not be changed even you are changing the locations of the points. That is a very important point. Okay. So, these are some points already we have discussed. This is a summary I can able to tell regarding the 2-dimensional Cartesian coordinate system, and this process already I have informed to you, that is x is equal to 2 is this one, y is equal to 3 is this one, and intersection point is this one. Then two coordinates, if I give two coordinates, what you are representing? X I am giving, y I am giving, you are representing a point. But if I give only one coordinate like x, if I give x value, you can draw a vertical line. If I give y value, you will draw a horizontal line. So, one coordinate is representing line. If I give nothing, that means x value I did not give, y value I did not give, this is representing the surface, the points are available on the surface. X is equal to constant is representing the vertical line, y is equal to constant is representing the horizontal line. As I said earlier, if I give 2, that is representing the point. What is the range of x? Minus infinity to plus infinity. What is the range of y? It is also from minus infinity to plus infinity, and ax cap direction and ay cap direction already I have informed to you, that is ax cap direction is perpendicular to x is equal to constant, ay cap direction is perpendicular to y is equal to constant. So, these are the things we have seen in our two dimensional Cartesian coordinate system. Now, two dimensional polar coordinate system. As I said earlier, whether we are using two dimensional Cartesian coordinate system or two dimensional polar coordinate system, these are for the representation of the points on a plane. So, this is also for the plane only, but here the coordinates are represented with rho and phi. What is rho? What is phi? That we will see now. The rho is nothing but, the definition of the rho is actually the radius of the circle, radius of circle. What is phi? Phi is the angle, phi is the angle measured from positive x axis in anti-clockwise direction. Every point is important, every word is important here. Rho is nothing but radius of the circle. That means, if I give rho value, you will draw a circle with the radius, with the given radius, by assuming the center is the origin. If I give the phi value, that is actually giving the angle measured from the positive x axis in the anti-clockwise direction. That means, it is about the straight line. Okay, phi is equal to some value, if I give, you will draw a straight line. Here already diagrams I have given. So, for example, rho is equal to phi I have given 5 meters, if I say rho is equal to 5 meters, and rho is the radius. I can give rho is equal to 5, I can give rho is equal to 10, I can give rho is equal to 1000, I can give rho is equal to infinity, I can give rho is equal to 1, I can give rho is equal to 0.1, I can give rho is equal to 0.01. You need to draw a circle with the radius 0.01. If I give rho is equal to 0.000001, it is also possible. You will draw a circle with radius 0.00001, but I can't give rho is equal to -2. You can't draw a circle with the radius -2 meters. Radius is a positive value. Okay, that means rho is a positive value. So, what is the range of rho? It can be 0. If it is 0, it is representing a point. So, 0 to infinity, I can say the range of the rho. Okay, range of the rho is nothing but 0 to infinity, like that I can able to tell, but I cannot take the negative values for rho. But in our previous case, in case of the two dimensional Cartesian coordinate system, the x value is changing from minus infinity to plus infinity, y value is also changing from minus infinity to plus infinity. But coming to this polar coordinates, rho is a positive value, remember that one, rho is changing from 0 to infinity, like that we can able to tell. Coming to this phi, okay, for example, if I give rho is equal to phi, you will draw a circle like this. Here rho is equal to phi, with the circle radius phi, you will draw a circle. So, from the center at any point on this particular circle, you can able to have the distance is phi only. Okay, that is about rho is equal to phi. Instead of giving the rho value, if I give phi is equal to 45 degrees, if I give phi is equal to 45 degrees, you will, that is actually representing a straight line. You see here, for example, this point I am taking. This point is making 45 degrees with the positive x axis in the anti-clockwise direction. This is the anti-clockwise direction. If you go like this, that is the anti-clockwise direction. Otherwise, you take this point. This point is also making 45 degrees only with the positive x axis. This point is also making the 45 degrees only with the positive x axis. All these points are making 45 degrees. If you take the trace of all these points, it is making a line. That means phi is equal to some constant if I provide, that is actually representing a straight line. If I give phi is equal to 60, this is the line. If I give phi is equal to 90, positive y axis we will represent. If I give phi is equal to 135, this is the line. Phi is equal to 215, this is the line. Like this, the lines are represented by this particular phi is equal constant. So, finally, now we can able to tell rho is equal constant means that is a circle, and phi is equal constant means that is a straight line. If I give both, what will happen? If I give both, that is rho comma phi is equal to phi comma 45 degrees. So, if I take this rho is equal to phi, I need to draw a x axis and y axis I have taken. This is x axis and this is y axis. Rho phi I am taking as 5 and 45 degrees. Okay. So, if rho is equal to phi, I can draw a circle like this with radius phi, and phi is equal to 45 means I can draw a straight line. Okay. These two are intersecting at this particular point. So, that point is available on the circle with radius phi, that point is also available on the straight line. Okay. So, this point is actually representing rho comma phi is equal to phi comma 45. Like this, we can represent any point on the two dimensional plane using this two dimensional polar coordinate system. So, we can answer all these things. Two coordinates if I give two coordinates if I give, that is representing a point. One coordinate if I give, that means if I give rho value, that is representing a circle. If I give phi value, I can represent a line, straight line. If I do not give any coordinate, again this is representing the surface. Rho is equal constant is representing the circle, we know phi is equal constant is representing the constant, sorry, phi is equal constant is representing the straight line, rho and phi is representing a point. Range of rho already I have mentioned, that is 0 to infinity. Phi range is found, phi range also important. Here if you see, phi is actually starting from positive x axis. On the positive x axis 0 degrees is there, 10 degrees, 45 degrees, 60 degrees, 90 degrees, 135, 180, here 215, 270, 315, and you can tell here 350 and 360. Like this the rho value can be changed. So, what is the range of the rho? 0 to 360, that is it, 0 to 360 degrees, or we can tell 0 to 2 pi radians. And again here same thing. What is the direction of the aero cap? What is the direction of the FA cap? Aero cap direction is perpendicular to rho is equal to constant. Rho is equal to constant is a circle. So, for this circle perpendicularly we have to take, and phi is equal to constant means it is a straight line. For this straight line perpendicularly we have to take. Okay. Those things we will see in the next slide.